In section 5.5.55, the question states how many different 10-letter words, real or imaginary, can be formed from the following letters: H, L, R, T, L, Z, L, V, L, L. Now, to create a word from a given set of letters, we are arranging the letters in a certain order. However, in this case, we have the added complication that we have been given some letters which are duplicates of each other. Since we can use each of the 10 letters we have been given only once, replacements are not allowed. So in this situation, we count permutations of non-distinct items without replacement. So a permutation of non-distinct items without replacement is the number of ways n objects can be arranged where order matters, in which there are n subscript 1 of one kind, n subscript 2 of a second kind, and n subscript k of a kth kind, where n is equal to n subscript 1 plus n subscript 2 plus all the way to n subscript k. The number of such permutations is given by the following formula. We have n factorial divided by n subscript 1 factorial times n subscript 2 factorial all the way to n subscript k factorial. Now, in the expression below, the appropriate numbers have been substituted into the formula, and we're going to evaluate this expression to find the number of 10-letter words, real or imaginary, that can be formed. So, if we take a look at this, okay, we know that n represents the total number of letters that we have. And so the total number of letters that we have is equal to 10. Okay, now let's take a look at the first letter, which is H. So the first letter is H, we're going to call that N1. And how many H's do we have? Well, we only have one H. So therefore, N1 is going to equal 1. Now, let's take a look at the second letter. Well, the second letter that's given, we're going to call that N2. Okay, and the second letter is L. So how many L's do we have? Well, we can see here that we have 1, 2, 3, 4, 5 L's. So therefore, N2 is going to equal 5. Okay, and then we look at the next letter, the third letter in this scenario, which is R. So how many R's do we have in this selection? Well, we only have 1. Then we look at the next letter, which is the fourth letter, which is T. So N subscript 4, since there's only one T, that means we have 1. Now the next letter is L, but we've already included it with the 5 choices. So we're going to then go to the next letter, which is Z. So the fifth subscript of N is then equal to 1 because we only have one Z. And then if we go to the letter of V, then we have N6, which is equal to 1 since there's only 1. So now we're going to substitute these values into our formula. So we have 10 factorial divided by 1 factorial times 5 factorial times 1 factorial times 1 factorial times 1 factorial times 1 factorial, which eventually gives you 30,240. So keep in mind here that our formula would have been the following. It would have been n factorial, and when we count up how many letters that we had n1 factorial times n2 factorial times n3 factorial times n4 factorial times n5 factorial times n6 factorial. Now again, it all depends on the amount of letters that were given. In this case, since there were 10, and these were the letters that we had to choose from to find out which one they represented.